Hello students, welcome to a new lecture of P block elements. In the last class, we were discussing about the allotrope of sulfur in the end. Now let us start different compounds of sulfur starting from its oxides and sulfur dioxide, right? Acids of sulfur we have to see, and one oxide of sulfur which is very common, which is sulfur dioxide. It has sulfur trioxide also is there, but the most useful is sulfur dioxide. So we will study about the preparation of sulfur dioxide and the properties of sulfur dioxide. Let us come to its preparation. How can you prepare sulfur dioxide is just, you might have seen the reaction in which carbon or coke or graphite, when it is burnt in the presence of oxygen, you get what? Carbon dioxide. So you are burning carbon in the presence in air to give you carbon dioxide, right? The same as that reaction, if you burn sulfur also in the presence of oxygen, if you burn sulfur in the presence of oxygen, what do you get? You get sulfur dioxide in the form of vapors, right? So that is also one preparation of sulfur dioxide, in which sulfur is burnt in the presence of air to give you sulfur dioxide. What is the next preparation? If you have any salt of sulfite, sodium sulfite, potassium sulfite, zinc sulfite, copper sulfite, whatever sulfite I am taking, I am not taking sulfate. What is the formula of sulfite? SO3 minus 2. If I take sulfite ion or any salt having sulfite and add any acids, all the acids like HCl, HNO3, H2SO4, all of them have what? H plus ions. If you add acid to the sulfite ion, you get sulfur dioxide and water. You get sulfur dioxide and water. This reaction is also reversible in nature, right? How to balance that? One sulfur, three oxygens, two hydrogens, right? So sulfite reacts with any acid having H plus ion to give you sulfur dioxide plus water. Now the next preparation of sulfur dioxide is from any ore. Ore, from where you get ores? From underground, right? Any ores in which, any minerals in which sulfur is present, what are they called as? Sulfide containing ores or sulfur containing ores. If you heat that ores in which, that minerals in which sulfur is present, if you heat that ores, or you can call it as roasting in the presence of air. If you roast the ores in which sulfur is present, roasting will be done in the presence of oxygen only. So if you roast any mineral in which sulfur is present, then you will get sulfur dioxide as a product. How many oxygens are here? 3 plus 2, 5. But here there is only 2. So what I will do? I will take 10 oxygens. So how many are here? Fe2 means minimum 2. Sulfur are 4. 4 2s are 8, 9, 10. So what I will do? I will take only 1. Okay, I have to take 2. Here 4 2s are 8, 9, 10, 11. How to balance that? 4, right? So now this is the reaction in which sulfur containing ores are burnt in the presence of oxygen. So what I do? 11 oxygens I take. If I take 11 oxygen, what happens? 2 sulfur, 4 Fe2O3 I get. I should make it to 4. Now how many sulfur? 2 4s are 8. How many sulfur dioxide? 8 sulfur dioxide. 16 plus 6, right? So it is 22 only, right? In this reaction also, whenever you are burning any mineral or any ore in which sulfur is present, you will get sulfur dioxide as a byproduct, right? These are the preparation of sulfur dioxide. Now we will look at the properties of sulfur dioxide, but before going to that, let us look at the structure of sulfur dioxide. The shape of sulfur dioxide is angular, right? It is having angular shape in which there are lone pair of electrons. It is having angular shape. Now let us look at the properties of sulfur dioxide. Sulfur dioxide is very much reactive with water. If you add sulfur dioxide gas, it is in the form of gas, is it? Right. If you take water, to that if you pass sulfur dioxide gas, if you take water in the form of liquid, sulfur dioxide in the form of a gas, it is very much soluble in water. Immediately after passing the gas, it becomes soluble. What do you get in the end? Sulfurous acid. What is the name of this? H2SO3 is called as sulfurous acid, whereas H2SO4 is called as sulfuric acid. Which acid do you get if you dissolve sulfur dioxide in water? Is sulfurous acid. Let me write the name. You get sulfurous acid. What is the next property of sulfur dioxide? Is it reacts with alkali. Which example of alkali have I taken? I have taken sodium hydroxide as an alkali. Not just sodium hydroxide, I can take potassium hydroxide also. Any base can be taken as an example. Sulfur dioxide. If you remember from yesterday's class, we have discussed about oxides, and in that there was acidic oxide. Which oxide was acidic? I told any oxide in which non-metal is present will act like acidic oxide, right? So if the acid is acidic, will it react with base or not? Yes. Because of that reason only sulfur dioxide is acidic oxide. It is reacting with base. If you add sulfur dioxide to acid, the reaction will give you some other acid, right? If you react sulfur dioxide with any other acid, the reaction cannot take place because both are acids. You cannot get, right? As oxide is having acidic nature, therefore you have to take a base. Which base? Sodium hydroxide as a base. Now let us see the product. If you react sodium hydroxide with sulfur dioxide, you get sodium bisulfite, NaHSO3, Na2SO3, sodium sulfite you get, plus water. The same sodium sulfite, if you react with another mole of SO3, you will get sodium plus water. If you react sodium sulfite with another mole of SO3 with water, the same reaction you do it again by adding some more SO3. Same reaction, right? Na2SO3 plus water. To that you add some more SO3. What do you get? Sodium bisulfite. Is it a salt or not? We already know that whenever base react with acid, you get salt. Which salt you are getting? Sodium sulfite is the first salt. Some more sulfur dioxide means another salt, which is sodium bisulfite, right? These are the two reactions in which sulfur dioxide is behaving like an acidic oxide to get salt in the end, right? Now what is the next reaction of sulfur dioxide? Is with chlorine. With chlorine gas, it reacts with dioxide, not trioxide. Sulfur dioxide reacts with chlorine to form sulfuryl chloride. What is the name of this new compound? Is sulfuryl chloride. It is used in the laboratory as chlorinating agent. It is used in the laboratory as chlorinating agent. Which compound? Sulfuryl chloride. Now what is the next reaction of sulfur dioxide? Sulfur dioxide. How to get sulfur dioxide? Right? If you take sulfur, burn it in the presence of oxygen, you get sulfur dioxide. Whatever sulfur dioxide you got, if you heat it again in the presence of oxygen, but there is a need of catalyst here if you want to heat sulfur dioxide with some more oxygen, right? So catalytic oxidation can take place for sulfur dioxide if you add some more oxygen. Normally without catalyst it cannot take place. So what is the catalyst? Is vanadium pentoxide. If you take sulfur dioxide with oxygen, and the catalyst is vanadium pentoxide V2O5, you get SO3. How to balance? 2 oxygen here, 2 oxygen here, but you are getting sulfur trioxide. 4 oxygens, 5, 6. So what I have to do? 3 2 is 6. How many oxygens? Right. So this is the way in which you convert sulfur dioxide catalytically into sulfur trioxide by using vanadium pentoxide. That is one more property of sulfur dioxide. What is the next property of sulfur dioxide? If you take Fe plus 2 salt, or if you take Fe plus 2 ion, you can convert it into Fe plus 3 ion by the help of sulfur dioxide. That is also one property of sulfur dioxide. How can I write that property? Sulfur dioxide can convert Fe plus 2 ion into Fe plus 3 ion. How? Is by this combination. What is the combination of these two? H2SO3. What happens here? Plus 2 oxidation state means 2 electrons are less. Plus 3 oxidation state means 3 electrons are less. That, what is the difference? Loss of 1 electron. So it is oxidizing iron from plus 2 into plus 3. That is the reaction. So sulfur dioxide is used in titration also to convert plus 2 into plus 3, but you cannot see the color change here because the color here and there are almost the same. Where can you see the remarkable difference in the color? In the next titration, in which MnO4, what is the name of MnO4 minus? Permanganate ion. What is the color of permanganate? Deep purple color, right? If you take potassium permanganate, which is having deep purple color, and sparse sulfur dioxide, what will sulfur dioxide do? Means it will convert potassium permanganate into Mn plus 2. That means Mn plus 2 don't have any color. Mn plus 2 is colorless. So now you can understand how much difference the color he is having. Before the reaction it was deep purple color, after the reaction it is just becoming colorless. Can you see the color change? Can you see that the deep purple color is converted into colorless, just like water it is. But this is deep purple color. Why? The change in color is because sulfur dioxide is reducing Mn plus 7 into Mn plus 2, or you can call sulfur dioxide decolorizes permanganate into Mn plus 2. Is it decolorizing or not? Is it disappearing the color of permanganate or not? Yes. So these are the important properties of sulfur dioxide. In some reaction it is acting like acidic oxide, in another reaction it is oxidizing others, in another reaction it is reducing others, right? These are different properties of sulfur dioxide. Now what we will see is oxoacids of sulfur, not oxides of sulfur. Oxide of sulfur is only one, but oxoacids are many. There are so many oxoacids of sulfur, which is sulfurous acid, sulfuric acid, dithionous acid, thionous acid, thiosulfuric acid, pyrosulfuric acid, peroxosulfuric acid. All of them are possible, but out of all of them, not every oxoacid is stable. There are only few oxoacids which are stable. So we are going to study only the stable oxoacids of sulfur. What is the meaning of oxoacid of sulfur? The acid in which sulfur. So we are going to study oxoacids of whom? Nitrogen? No, sulfur. So what is the condition? It should be acid, that means H plus ions should be there. It should have hydrogen and it should have sulfur. With this combination, how many acids you can get is the heading of oxoacids of sulfur. Oxo means oxygen, acid means H plus, sulfur means sulfur should be there. With these three combination, how many acids you can make? You know one acid which is famous. What is that? Sulfuric acid. What is the formula? H2SO4. Is it having oxo? Yes, oxygen is there. Is it having H plus? Yes. Sulfur is present? Yes. This is only one example. What is the name? Sulfuric acid. But there are many oxo acids of sulfur. Let us write the names. Sulfurous acid. Next is sulfuric acid. Next is thionous acid. Next is dithionous acid. Next is thiosulfuric acid. Thiosulfuric acid. Next is pyrosulfuric acid. Next is peroxosulfuric acid. Right? There are so many acids, but all of them are not stable at room temperature. Who are stable? That acids only we will study. Okay, what are those? Let us see. And for each acid you have to remember the correct formula and even its structure also. If you draw the structure, oxidation state also we can calculate, right? Let us see. What is the first acid? Sulfurous acid. I am writing all the names of acids which we are going to study now. What is the second acid? Sulfuric acid. In the exam for 2 marks you may just get a question. Draw the structure of sulfuric acid with its oxidation state. Means correct structure, correct oxidation will give you 2 marks. You don't have to write anything. Okay. Sulfuric acid. Next is pyrosulfuric acid. Next peroxodisulfuric, pyrodisulfuric and peroxodisulfuric acid. Sulfurous means only one sulfur. Sulfuric also means one sulfur. Disulfuric means 2 sulfur. Disulfuric means 2 sulfur. Right? Now let us look at the formula. What is the formula of sulfurous? You have already seen in the previous reactions. H2SO3 is the formula for sulfurous acid. What is the formula of sulfuric? Everyone knows. H2SO4. Now what is the formula of pyrodisulfuric acid? H2S2O7. What is the formula of peroxodisulfuric acid? H2S2O8. 2 sulfurs you are taking? 2 sulfurs you are taking. Now shall we draw the structure? Let us. One, two, three. Okay, 3 oxygens are over, 1 sulfur is over. H. This is one lone pair. Okay, oxygens are only 3, so this is vacant. 4th oxygen is not there. But here what happens? 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. How many hydrogens? H. Right, this is the structure of sulfuric acid. Here also what do you do? 1 oxygen, 2 oxygen, 3 oxygen, 1 oxygen, 2 oxygen, 3 oxygen. Right? How many hydrogens? 1, 2. 1, 2, 3, 1, 2, 3. But here how many oxygens they are asking? 7. 1 comes in between. Right? So this is the structure of pyrodisulfuric acid. Pyro means in the center you get only 1 oxygen. That is called as pyro. Okay. Now peroxo means only difference is peroxo have 2 oxygen in the center. Remaining everything is same. 1, 2, 3. 1, 2, 3. How many hydrogens? 1, 2. So 3 oxygens this side, 3 oxygens this side, 6, 7 and 8. So hydrogens are 2. Always here in all the acids there are 2 OH, right? So the formula for peroxodisulfur, peroxo means hydrogen peroxide, we know, right? H2O2. Right? Wherever peroxo comes, you should have this in the center. Remember, don't get confused in between these two. Right? So we are having only 4 oxo acids of sulfur which are very important. Now we know the structures, right? Let us calculate the oxidation states. Calculation of oxidation state of sulfur is very easy. How? Each hydrogen should always have +1. So how many hydrogens? 2 into +1. Plus, do you know the oxidation state of sulfur? You don't know. Write X. How many oxygens? 3 oxygen. Each oxygen has -2. What do you get? 2 plus X minus 6 is equal to 0. So X is equal to how much? Plus 6 minus 2. X is equal to +4. So on each sulfur, the oxidation state of sulfurous acid is +4. Shall we go to the next? Here also 2 into 1 plus X plus 4 into -2. What do you get in the end? X is equal to 4 to the -8 becomes +8. 8 minus 2. X is equal to +6. So on sulfuric acid, the oxidation state of sulfur is +6. Shall we go for the next? Yes, it's same. 2 into 1 plus 2 into X plus 7 into -2 is equal to 0. 2 plus 2X minus 14 is equal to 0. So 2X is equal to 14 minus 2. 2X is equal to 12. X is equal to 12 by 2, which is +6. Right? Same way, in peroxo disulfuric acid, what do we get? Let us see. 2 into 1 plus 2 into X plus 8 into -2 is equal to 0. 2 plus 2X minus 16 is equal to 0. 2X is equal to 16 minus 2. 2X is equal to 14. X is equal to 14 by 2. What is the value? +7. So on each sulfur, the oxidation state is +7. Okay. These are the 4 oxo acids of sulfur. We have to know the correct formula and the correct structure. Then only you can easily calculate the oxidation state. Shape is already known, oxidation state is already known. Whatever can be asked for 2 marks. They can ask you about the complete information about one acid, or they can ask you the structure of all the acids, but it's important. Okay. The next compound is sulfuric acid, but we don't have. Now in the next class we will move on to the next group elements. What are they? They are 17th group element, which is nothing but halogen family. Okay. Thank you.